So in chapter 13, we are going to talk about the general addition rule. We will solve some examples on them. I picked some of your homework problems. And then we will also talk about conditional probability. We would also talk about the multiplication rule. Learn how to present information on a Venn diagram. I'm sure most of you know Venn diagram from high school. So we are going to learn that. Tree diagrams, if we have time today. If we don't have time today, we'll do tree diagrams on Monday, next Monday. So let's start with the general addition rule. So we've already talked about general addition rule when we dealt in chapter 12, but I just wanted to point that out. So the general addition rule, as it says that when you are trying to find the probability of, say, A or B, we add probability of A plus probability of B, probability of A plus probability of B minus probability of A intersection B. This is so because, for example, like last time I showed you, this is probability of A. Okay? Is that okay? So we have counted this one. This is probability of B. So you see, we've counted this space twice. We've counted it in A, we have counted it in B. Is that okay? And so we need to subtract one of them. Does that make sense? This is A. And then, so we've taken this guy. You see? And then this is B. You see? So you see, we have counted A and B. In counting probability of A and B, we have counted the intersection twice, one with A and then the other one with B. Is that okay? And so we need to subtract one of them. Is that okay? That is why the addition rule is this way. And then also when we want to write probability of A or B, we could also use this sign here, the union. Is that okay? This union means or. Is that okay? This sign here means and. Is that okay? So this one means or, this one means and. So this is the general addition rule. Any question on that? Now let's see the general addition rule in practice. So I want you to read this and then discuss with your friend sitting next to you what you think or how you think we are going to find or we are going to answer this question. Is that okay? Read it and discuss with your friend sitting next to you. Okay, I would answer this one and then you do the next problem too in groups. So look at how I am going to answer this. Is that okay? So when we read, we are told that a survey of college students asked the question, are you currently in a relationship? And are you involved in club sports? Is that okay? Now, the survey found that 33% were in a relationship, 25% were involved in sports, 11% responded to both. That means that the 11% said that they are both in a relationship and sports. Does that make sense? Okay. Now,
Is that 11% part of the 33 and 25%, or
Yeah.
is it separate? It is
It's
part of it?
separate. So like we have that these people say we are in sports, these people say we are in relationship, and then these people say we are both. Is that okay? So to answer your question, when we get to how to show that in the Venn diagram, you get to see how we are going to do that, whether we are going to show it in both or we are going to learn how to separate them. Is that okay? Good. But anyway, that's a good question. So to be able to answer this question, look at how I'm going to answer them. First and foremost, let's say that let R equal to you being in a relationship. Is that okay? What variable should I use for you involved in sports? S. Do you all agree S? Okay. So S involved in sports. Good. So based on this, what is probability of R? 0.33. Do we all agree to that? Is that okay? Good. Probability of S, 0.25. And then involved in both, that means that probability of relationship and spouse. I told you that this sign means and. Is that okay? And that would be what? 0.11. Are we all clear on this one here? Any questions so far? We all good? Okay. Now the question is saying that what is the probability that a randomly selected student either is in a relationship or involved in athletics? So it means that we are looking for probability that you are in a relationship, or we could use the you, or we could also do or sports. Does that make sense? That is what we are looking for. This we do not know. Is that okay? How do we answer this? We are going to use the general addition rule. Is that okay? So general addition rule says that then this implies that probability of R or S equals probability of R plus probability of S minus probability of what? R intersection S. Is that okay? In the note, I used A and B as just variables. Is that okay? So it's very important that you write this general addition rule in your cheat sheet. Does that make sense? Okay. So now this gives us what is the probability of R? You see the way I've been able to write that down easily. So I just look at that and I write it. So I have 0.33 plus probability of S 0.25 minus 0.11. What do we get? 0.47. So what does it mean? It means that what 47% of the students is either in a relationship or involved in sports. Is that okay? So you see how we implement the addition rule. Does that make sense? Good. So this is the solution. It is the same thing I have done here. Now, I want you to try this and then compare it with your friend sitting next to you. Compare your answers and then we would now come and then do it together. So try to do this. I picked this problem from your homework. Write down and compare. It's very good to write down and learn here. That way when you are doing your homework, you can remember what you did in class. Does that make sense? Anybody wants to share the answer? 0.4. Anybody else? You got that too? Okay. So to do that together, I picked this from your homework. It says that 33% of people have a dog, 17 percent have a cat, and then 10% own both. So to answer this, I say, okay, let D equals what? People with dogs, right? And then C equals what? People with cat. And then, so when we do this, it means that what is P of D? What is P of D then? 0.33. What is P of C? 0.17. And then what is P, D, and C? 0.1. And so to find the probability that someone owns a dog or a cat, it means or, you see, we are going to use the general addition rule. Is that okay? So we are going to have P, dog, or cat. Or you could use or. It's the same thing. Is that okay? This symbol here means or. Is that okay? Good. And then the general addition rule says that probability of D plus probability of C minus probability of D intersection C. So this gives us 0.33 plus 0.17 minus 0.1. And that answer gives us what? 0.40, correct? Okay, so it means that 40% of the people owns a dog or a cat. Is that okay? Good. And so this is the solution I also presented. Okay, now we want to learn how to answer these questions using a Venn diagram. A Venn diagram is a picture, is a visual picture to represent the relationship between different groups. When you have a Venn diagram, it makes answering multiple questions very easy. Is that okay? Does that make sense? So, how do we represent this information on the Venn diagram? It's very important that you understand how to do this. When you learn how to do the Venn diagram, many questions are going to be very easy. You can just look at the Venn diagram and then write the answer. Is that okay? So let's learn how to do that. So to be able to represent this information on the Venn diagram, this is the first example we did. So we know that P of R is equal to 0.33. P of S is equal to 0.25. And then P of R intersection S is equal to 0.11. 1. So to represent the information on the Venn diagram, you draw two circles. First, let's draw a box. Do you see? So we first draw a box. And because we have only relationship and sports, we draw two circles. Is that okay? So let's draw two circles. I drew the circle this way because when I looked at this, I have the intersection. It means something that they both have in common. Is that okay? That is why I drew the circles to overlap. So to draw the Venn diagram, I first draw a box. Is that okay? I'm drawing two circles because in the problem, I only have relationship and sports. Is that okay? Good. Then the question is, okay, why didn't you draw the circles this way? Right? Because we are drawing two circles. But we choose to draw it this way because the problem gave us the intersection. Is that okay? So we need to draw the circles to overlap. Is that okay? So now to be able to represent this information on the Venn diagram, let's label our Venn diagram. So we call this first one here. Let this one be R. This circle here is R. Is that okay? And then this one is what? S. Does that make sense? Good. What is the easier information to be able to put on a Venn diagram? The intersection. We know the intersection is what? 0.11. Is that okay? Where do we put that? In the middle. Is that okay? The intersection, which says that relationship and sports 0.11. Is that okay? So draw two circles and then first put the intersection. Does that make sense? Good. Now let us put the other ones. We know that P of R is equal to 0.33, isn't it, from here? Is that okay? This circle here is R. This whole circle here is R. Is that okay? And so what do we put here? If this is 0.33, here is 0.11. So what is 0.33 minus 0.11? 0.22. So we put 0.22 here. So that when you add 0.22 plus 0.11, you get 0.33. Do you see how we put that? We don't put 0.33 here. Is that okay? Okay. Now we also know that P of S we also know that P of S is 0.25. Is that okay? What do we need to put here? Now, S is the whole of this thing here. We need to put a figure here. So when we add this and that figure, we are going to get 0.25. Is that okay? So what is 0.25 minus 0.11? 0.14. Does that make sense? Okay. So this is how to put the information. Now we want to put one. How about those who don't do any? They are not in a relationship, they are not in sports. How do we get that? To be able to get that, let's add all this. What is 0.22 plus 0.11 plus 0.14? What do we get? So to be able to get that, remember probability means everything should be equal to what? 1. So 1 minus 0.22 plus 0.11 plus 0.14. And then she said 0.47. So 1 minus 0.47. should be equal to 0.53. I put that number here. They are not in relationship, they are not in sports. So you see why I put that. Does that make sense? Okay. Any question on the Venn diagram so far? Okay, no questions. Let's proceed. So I decided to also show you how to do that here too. Is that okay? Good. So now let's learn to answer some questions based on the Venn diagram. So let me put the Venn diagram here again. So this is the first, and then we have two circles. And then this is relationship, this is sports. Here was 0.11, and then 0.22, and then 0.14. And then here was 0.53. Okay? I just copied the first Venn diagram that we did. Is that okay? Now we are going to use these Venn diagrams to answer these questions here. Now, the first one is that what is the probability that a randomly selected student is not in a relationship and is not involved in sports? What do you think that answer should be? Kimberly, what do you think that? Okay, 0.53. Good. So that is 0.53. Because that is here. You are not in sports, you are not in relationship. Is that okay? Good. And then is involved, is in a relationship, but not involved in sports. So it's in a relationship. So you see, it's in a relationship, but not involved in sports. So that is 0.22. Is that okay? And then we are told the last one says that what? It's either in a relationship or in sports, but not in both. So you're in a relationship and in sports, but not in both. So that should be what? 0.22 plus 0.14, 0.36. Does that make sense? You are in a what? Relationship or sports, but not in both. So you see, the Venn diagram helps us to answer problems like this. Any questions? Okay, if no questions, so this is what I did. So if you are not in a relationship and not in sports, last time I showed you what the complement is. So it's this. This is how to write that. Is that okay? So not in sport, not in relationship, R complement. Not in sports, C complement. And so these are those answers. Now, I want you to draw the Venn diagram for this. Is that okay? And then let's try to answer these questions. Don't look at the solutions. Draw the Venn diagram for this. When you draw it properly, it means you've learned. If you make mistake, it means you learn. Is that okay? So let's do it together. So when we read this, we see that we could say that we should let H equal to have a home phone. And then C equals have a cell phone. Is that okay? Now, how do we show this? So we draw two circles. So before we draw two circles, we can see that probability of H is equal to what? What's the probability of having a home phone? 0.45. Probability of C equals what? 0.96. And then probability of H and C is equal to what? Those who have both is 0.42. Does that make sense? Okay. How do we show that on the Venn diagram? I draw two circles. And then let's say here is H, here is C. Is that okay? Easy to show the intersection first, 0.42. So if 0.42, what do you think would be here? Home is 0.45. Is that okay? What do I need to add to 0.42 to get 0.45? Yeah. Cell phone is 0.96. What do I need to add to 0.42 to get 0.96? 0.54. Do you agree to that? Okay. Now, since we have this, how do we get neither? Let's add all this and subtract from 1. What do we get? So here is going to be what? 0.01. Does that make sense? How many of you got the Venn diagram correct? Okay, good. So this is how to show the information in the Venn diagram. Now, let's come to a home or a cell phone. To get that, you can add all these things here. You'd get that. Is that okay? Or we could also do home or cell phone equals P of H plus P of C minus P of H intersection C. P of H is 0.45 plus 0.96 minus 0.42. What do we get? 0.99. So here is going to be what? 0.99. Is that okay? Now, neither a home nor a cell phone. We can use the Venn diagram. It's here. Neither a home or a cell phone, 0.11. Is that okay? A cell phone, but not a home. What do you think that answer would be? A cell phone, but not a home. 0.54. So this is made easy by the Venn diagram. Is that okay? So it's very important to master how to represent this information on the Venn diagram. So this is the same thing we just did. Now, we are going to talk about conditional probability. So a conditional probability is the probability of an event occurring given that another event has already occurred. Is that okay? So the conditional probability is the probability of an event occurring given that another event has already occurred. Is that okay? For example, the probability of someone getting a headache given that the person already has a COVID. Does that make sense? So the person already has a COVID. They are trying to find the probability of you having a headache. Is that okay? So that is a conditional probability. And we write it this way. It's very important. So anytime you see this, it means the probability of A given that B has already occurred. Is that okay? So it's very important to understand how we write that. So when you see this, it means probability of A given that B has already occurred. And so the formula for that, which you can write in your sheet, is this way. So probability of A given that B has occurred is the same as probability of is equal to probability of A and B divided by probability of B. Probability of B given that A has occurred is the same A and B, but we divide by A. So the only trick is that you see when here is what? B, we divide by B. When here is A, we divide by probability of A. So it's very important that you write this in your sheet. This is the conditional probability. Okay, let's try to look at some examples of the conditional probabilities. Let's start with a simple one. So here we have a contingency table. And we want to answer the following questions. So here, the contingency table gives count of students by their goals and sex. So you see sex here and then goals there. Now, what is the probability of a girl? Now, let's look at girl. The total number of girls is what? 251. Is that okay? Divided by the what? The total. So that is 251 divided by 475 gives you that. Probability of a girl and popular. So you are a girl and you are popular. We are here. Is that okay? So 91 divided by the total gives you that. Probability of sports. This is sports. The total sports is what? 90. 90 divided by the total gives you this. Now, probability of girl sports given that you are a girl. So let's do that. So probability of what? Sports given that you were a girl is equal to probability of sports and a girl divided by probability of what? Girl. Is that okay? It is based on this formula here. So we can see from here, sports and a girl, probability of you being a sports and a girl. So you are in sports and you are a girl. So what would that be? Sports and a girl is this. Is that okay? So that's going to be what? 30 divided by 478. Divided probability of a girl is also 251 divided by 478. This is the same thing as what? 30 divided by 251, which is this. Is that okay? Any questions so far? Okay. And then now, we also want to talk about the multiplication rule, which we did in chapter 12. In chapter 12, we learned about this, and we said that this only applies if A and B are independent. If they are not independent, this does not apply. And we actually did an example when we asked about if two cars are on the road, whether their speeds are independent. We did this example. This rule only applies if A and B are independent. Is that okay? Otherwise, if we don't care about independence, this is the multiplication rule. Is that okay? And how did I get this? You don't need to worry. Remember, what is probability of B given A is equal to probability of B and A divided by probability of A. So if I want to make this guy here the subject, is the same as probability of B and A is equal to P of what? B given A times P of A, which is the same as what? That. So this formula was derived from the conditional rule. Is that okay? Good. Now let's look at this problem from your homework. So we will do this problem together. So it says that the probability that an adult has high blood pressure and or cholesterol are shown in the table below. Now, they want you to round your answers to 3 decimal places. So when we look at this table here, this is cholesterol. So high cholesterol and then okay. Is that okay? So you have no problem. Or you have high blood pressure and then okay. You don't have high blood pressure. Now, the first question, what is the, so remember, what is this table? This table is a what? Probability table. Is that okay? So now let's answer the following questions. Question 1, what is the probability that a man has both condition? That means that you have high cholesterol and high blood pressure. What do you think that would be? 0.19 because it's here. This is where they all meet. Is that okay? You see high blood pressure and high cholesterol. So that is what? 0.190. Next question. What is the probability that he has high blood pressure? What do you think that would be? This is high blood pressure, isn't it? So, yeah, you add both of them together. So to be able to get high blood pressure, look at where I circled. So it's going to be what? 0.19 plus 0.16. Do we see that? That is high blood pressure. And so when you add both of them, what do you get? So 0.350 because we are told to round to 3 decimal places. Okay, good. Now let's come to see what is the probability that a man with high blood pressure has high cholesterol. So somebody who has high BP has high, so you are looking for the probability that somebody who already has high BP has high cholesterol. So we write that probability of, now we are looking at probability of what? Somebody with high blood pressure. So you already have high blood pressure. So let me put this thing here. Let me put B here. Is that okay? Just to show high blood pressure. Has high cholesterol. Do we see how I wrote it? The condition you already have is here. Is that okay? The probability I'm trying to compute is here. Is that okay? Now, based on this, now let's look at the rule. This is the rule. So when we have this, it means probability of what? C and B divided by probability of what? B. Does that make sense? So this shows high cholesterol and high blood pressure. That is what? 0.19. Is that okay? And then high blood pressure. which we already did here, to be 0.35. When you do this, what do you get? What is 0.19 divided by 0.35? 0.54. I think it's 3 decimal places. When you do you get 0.54? 3. Yeah. Now let's look at the last one. What's the probability that a man has high blood pressure? If it's known he has high cholesterol, so we already know that you have high cholesterol. Now we are looking at that you have high blood pressure. So this is also the same as P, B, and C divided by P of C. Same 0.19 divided by probability of have high cholesterol is going to be what? 0.19 plus 0.27. Is that okay? Look at high cholesterol. Does that make sense? So 0.19 plus 0.27. What do you get? 0.46. It's the same thing we did here. Everything I think should be, so 0.1 divided by 0.46, so I got 0.43. So this is also the solution. Good. And then we would continue with the tree diagram on Monday. So make sure that you start your homework and then we'll finish this on Monday.